wanted to give you a bit of a perspective, let's say, starting out from the science side, from the global down to the local, down to the Jarrah forest. So I'm going to ask you to strap into your seats. And I've got quite a few graphs to get through, but there'll be lots of questions I can ask along the way. But I wanted to just give you the whole picture. I've been working on the international climate regime now ever since it began, since the late 1980s. I've been working on all of the scientific assessments. We now have the Working Group 3, IPCC, the economics assessment now just starting in the next 24 hours or so. So, very busy time. But I am, as Basil has hinted, very concerned about the Jarrah forest and forests here in general. Look, the Paris Agreement, the most important part of it in a way is the 1.5 degree limit. It's expressed in fairly legal language. I had the privilege to be in the very front line of negotiating this in Paris with the overall ambition package, but it refers to limiting the warming to 1.5 degrees. Now, as I'm going to step through here, that is a very, very important number, not just for the Great Barrier Reef, but for the forest in this state. The Paris Agreement matters because we know now from the IPCC assessments and basically a generation of work by the scientific community that every increment of warming matters. It turns out that 1.5 degrees is quite a critical level where many systems start to cross into a very high danger zone. This is what we call the burning ember diagram over here on the left, first pioneered in the third assessment report in 2001, where we put this together to show for policymakers how impacts scale with warming from 0 pre-industrial through to 4 or 5 degrees. And you can see that for unique and threatened systems like the Great Barrier Reef, this extreme danger zone starts to happen close to even a bit below 1.5 degrees. I'm not going to unpack this completely, but the thing is to note here that these are the things we're worried about here, unique and threatened systems, things like the Jarrah forest, things like the Great Barrier Reef, some human systems and so on, and they are very sensitive to every little bit of warming. And that's not something we knew from the beginning of this process, but it's something that's become more and more obvious in the last 10 or 15 years as we've got a better handle on climate projections. Now, where are we standing now? Well, actually, we're a long way from 1.5 degrees. I also, part of my day job is to run the Climate Action Tracker with my colleagues at the New Climate Institute, and we, for the last decade or so, have been working out what the total effect of countries' promises and their actions stack up to in terms of global warming. So, the policies and actions stack up to around 2.7 degrees of warming by 2100. There's a bit of black magic and all this stuff, but if you think about it for a minute, how do you estimate emissions 100 years in the future? It's a long story, but we do it. It's published in good journals, so it's probably okay. Targets are 2.4 degrees. This is a really bad story, looking at it now, but it has improved from Paris when we're looking more like 3.5 degrees. The best part of this now is if all of the net zero promises put forward by countries, the optimistic scenario here came about, actually did it, which is a big if, we'd be down to 1.8 degrees. Still too hot for important natural systems. Now, we know that warming is unequivocal. We know that the warming that we've observed is very strongly linked to human impacts on the climate system, mainly through the emissions of greenhouse gases. So this is one of the very, very strong findings from the IPCC. We know that the warming that we're observing is unprecedented over very long periods of time. It simply is something that is extremely unusual, both the warming, the CO2 concentration in the atmosphere, and many other things. Now, to emphasize the point about every increment of warming mattering, I'll just show this figure here, which is for heat extremes, right? And heat extremes are increasing quickly. This is both intensity and extent of heat extremes. By the time you get to 1 degree, 2.8 times more likely to occur, 1.5 degrees, 4.1 times, 2 degrees, 5.6. The thing to note here is that every half degree of warming is bringing on a more and more severe set of heat waves and heat extremes. And this applies to many other metrics, including extreme precipitation. I very much think that by the time the community's done the attribution studies on the floods on the east coast, they'll be very strongly linked to warming. Now, we expect to see quite a lot of rise in Australia. We've already seen about 1.4 degrees of warming since 1910 across the Australian continent. We expect ongoing and sustained warming in the future. I'm not going to go into too many details. The IPCC unpacked in its recent physical science assessment basic fact sheets. They're fairly readable, so I'm putting that here to make you aware of them. You can go and find them, but not to step through them. But we're really going to be focusing in this talk about heat extremes and drought, because they are the things that are really punishing the Jarrah forest. So what are we observing in the southwest? Well, we've got quite strong rainfall declines, of order 20% since 1970, occurring principally in the southwest part of the state. Quite similar but greater than what we've observed in southeastern Australia. This is resulting in the rainfall zones moving gradually southwest. I guess many of you are familiar with this sort of figure that the Bureau of Meteorology produces, but all of our rainfall zones that we typically think about constraining different types of agriculture are moving southwest. And along with that is going quite a lot of changes in our ecosystems. So we're seeing the winter rainfall observations in southwestern Australia really quite extreme. I think they're one of the fastest reductions on the planet anywhere. And what is worrying is that they're tracking at the bottom end of the climate model range. So they're going faster than we would expect, in other words. And the outlook is for that to continue. This is another view of the same thing, also produced by CSRO and colleagues, showing very much the same pattern. And you can see that by the 2090s, the changes in southwestern Australia are really extreme. That's under warming of, I think, about 4 degrees by 2100. Wildfires are increasing in extremity. Those of you who live in Denmark have seen the mess out there. I was just down there the weekend before last. Really quite shocking. Now, just to summarise, things in southwestern Australia have changed a lot. 20% rainfall decline in the southwest region. One of the first attributable declines, that is declines in rainfall attributed to global warming, or the combination of global warming and stratospheric ozone depletion. What is also very relevant, particularly for forests, is that there's an amplification in the decline in stream flow. So we're getting roughly double the reduction in stream flow than we get compared to precipitation changes. Quite typical of semi-arid ecosystems, but one you might not have expected here, but it's having a big impact on forests and all the things that live in the forest and depend on it. So we expect this decline to continue. I think, frankly, 10% rainfall by 2030 decline is fairly conservative, actually. I think, as I showed you, the model projections are really not picking up the rate of reduction that we presently have. And the runoff reductions are predicted to continue roughly 2 times the annual reduction in annual rainfall. Now, we're also seeing these effects in agriculture. Although we've had a record crop last year, it was a combination of circumstances that led to that, but the longer term reduction in productivity is quite evident. Farmers here are really great at picking up on yield, improving efficiency and so on, some of the best in the world, but climate change is beginning to outrun them. And that's due in part to the rainfall changes I've shown, heat and drought. We're also seeing, this is where I'm starting to get into the ecosystem side, we're seeing some really dramatic changes in our marine and terrestrial systems, and this has been well covered in the scientific literature. I mean, there's been literally 10 or 20 papers published in the last decade on the really big changes and major changes happening in Australia's terrestrial and marine environment, and a lot of these changes are focused in the southern part of our continent. In the marine area, we've had really extreme heat waves which have caused great damage to Ningaloo, to Shark Bay and so on, damage from which the system's not recovered. In the terrestrial environment, there are really big problems emerging. A lot of this has been driven by extreme heat and drought. This is just an extract from the Perth Airport weather records, which shows how quickly the average number of days above 40 degrees has been increasing since the first decade of the last century, right? So that this year, 2021 and 2022, we've had more days above 40 degrees, so-called extreme heat days, in a calendar year, or part of a calendar year. This year's only just started, compared to any other average 10-year period. And what's of concern here is that this does appear to be running faster than the contemporary projections. Projections on the right, on the left, right-hand side, your right-hand side are fairly old now. The most recent models that we're looking at are picking up much more extreme increases in these kind of heat extremes and drought. Now, converging on the Jarrah forest, it's become quite clear, and it's been a bit of a surprise to me, actually, I must say. Not that I'm an ecologist, but I would have thought the Jarrah forest would have been quite robust to a bit of drying and heat, but it turns out not. So, what we're seeing here is deepening drought and higher temperatures across this part of the northern Jarrah forest. This is from a paper in Environmental Research Letters recently, and you can see the figure here is showing the changes in precipitation, millimetres per year, compared to the 30-year period around 1951 to 1980, with the period 1981 to 2010, before the 2010-11 drought, right? So what you see here is a pattern of increasingly strong declines in rainfall. Obviously it's quite extensive throughout the southwest, but very much focused in the northern Jarrah forest. And also quite consistent with what we would see from the models as well. So, as a consequence, we've seen and observed the first really big shocks from climate change in the forest here, with large-scale loss of parts of the Jarrah forest in the north in the big drought and heat wave of 2010-2011. We've got a lot of discussion in the scientific literature. I'm sure many of you even know the scientists have been doing this, but sudden forest collapse, right? It's a thing. It's happening in other parts of the world, and we're observing it here. It's been predicted for a long time. Now, the most recent IPCC impacts report here, just released a few weeks ago, gives an honourable mention to the Jarrah forest, I'm afraid. Some forest ecosystems, including the northern Jarrah forest, are projected to transition to a new state or collapse due to hotter and drier conditions with more fires. So that is the synthesis of what we have learnt, the scientific community has learnt about the Jarrah forest essentially in the last decade, since the first big drought impacts happened. Prior to then, I think if you go back, you'll find people were still wondering about what would happen under drying. Well, it might cause some slowdown in growth, etc. But I don't think we really anticipated that this forest was actually climatologically on the edge. So, just looking now at the overall picture and why 1.5 degrees is important. I'm afraid this is a fairly messy picture. It's because we're just really processing the latest generation of climate models. What it shows is an increase in heat wave risk, right? And the thing to take away here is there's two kinds of temperature pathways shown here. One that's very close to the Paris Agreement in green, and another one which is very close to the current policy pathway we're on, the 3-degree warming that we're getting out of current policies at present, roughly. And the thing to take away here, it's mapped, it's projected down to this southwest part of Western Australia, is however you measure the heat wave indexes, and there are multiple ways to do it, I get confused about them, everyone has a new one. But the bottom line here is that the only way to limit the rapid increase in the exposure to heat extremes, however you calculate it, is by limiting global warming. See, at 1.5, 1.7 degrees level, there is some increase, but it's not fundamental. But if you don't limit that warming, if you don't start reducing emissions globally to the levels needed, then you will see this rate of exposure to very hot heat waves and hot days increase quickly. There's another way of looking at this as well. So this just gives you the maximum temperature in a given year across each period. The same thing as you might imagine. Rapidly increase in the number of and extent of the maximum temperature days. Stay roughly about 1 to 1.5 degrees above the 1985-2010 average, but if you don't limit warming, it increases quickly. Now, if you're going to reduce the exposure of the jarrah forest to these kind of pressures, you've got to really get on a pathway that limits warming. Let's skip over that. Soil moisture is another big one. Sorry, my local graph didn't work, so I've given you a picture here of the soil moisture changes projected at 1.5 and 3 degrees warming at any time in the future compared to the most recent few decades. 1.5 degrees, you do see significant reduction in soil moisture, consistent with what we're already observing. By the time you get to 3 degrees in the southwest corner, you've got really extreme reductions in soil moisture. Right? So that adds to the picture that I'm trying to portray here, that we really do have to think about how to reduce greenhouse gas emissions. So this has come to the final part of my talk about greenhouse gas emissions. In WA, they're increasing. I guess everyone knows that. I think apart from the Northern Territory, we're the only state with a fairly healthy ongoing increase in greenhouse gas emissions. Most other states, for different reasons, are reducing. So, how do the bauxite and alumina industry stand in relation to Western Australia's emissions? It's an interesting question. You know, I couldn't find a publication on it. I think the last one that was done was something I did about 40 years ago. But anyway, our modeller got together and pulled all the numbers together, and essentially what you see here, this is a picture of what fraction of primary energy use in the fossil fuel area, coal, gas and petroleum products and diesel, are being used by the bauxite alumina industry in the southwest. So for coal, surprisingly high fraction, heading towards about 50% now. That's principally used at the Worsley alumina refinery. Petroleum, surprisingly high number, about 20% or so of all the diesel used in the state, between 20 and 30% is consumed in the industry down here. I was also surprised. We went back and checked, and well, all these conveyor belts, all these trucks, everything moving around, it's quite big actually. And gas was surprisingly low, actually, around 5%. It used to be a lot higher, but the whole energy system has grown here. Now, converting that to emissions, we have also the loss of forest to account for. The bottom part of this figure is showing the actual emissions from the fossil fuel consumption of the bauxite alumina industry I showed you, heading towards 8 million tonnes a year. I'll share what that means in a minute. And forest emissions, about 5 or 8% of that, all up. Now, what that means in terms of the relative fraction of the state's emissions, this is showing, again, the fuel combustion emissions in blue, forest emissions from clearing the forest, the jarrah forest, and added together what the fraction of state emissions are. So decreasing from around 16% to 14% recently. So a surprisingly high fraction of the state's greenhouse gas emissions come from the bauxite alumina industry, right? So that means that this industry, whatever else it's doing to the environment, also has to deal very aggressively with its greenhouse gas emissions. Now, to get to limit warming to 1.5 degrees, the whole world has to have an emission pathway that looks something like this figure here, right? Peaking soon, dropping close to net zero by around 2050, right? You can discuss which decade, but that's the big picture. I think everyone knows it, that we've heard. We have to get to zero emissions. Now, why do we have to get to zero emissions? Because from the physics of the problem, once you get to zero emissions globally, zero emissions of carbon dioxide, then you will halt warming within a decade or so, right? There's not that much inertia in the system, so it's absolutely critical to get there. And the faster you do it, the faster you'll stop the warming. Of course, it's not a trivial issue because there's huge developing countries out there. This is a graph we did a few years ago as a result of a detailed study for how Western Australia would and could do it. The common story in all of these pathways is you have to decarbonise the power sector. I'm not going to go into any detail about that, but you really have to decarbonise the power sector quickly, so you can decarbonise transport, you can decarbonise industry, and of course we've got this natural gas problem here, which I'm not going to go into right now, but it's big. So, now to get to net zero in Western Australia, we've got a lot of agriculture, and it's very difficult to get rid of emissions in agriculture, particularly from animals and so on. So you're going to need forests storing carbon to offset against the remaining greenhouse gas emissions around 2040, 2050. And you're going to have to basically keep recent levels of storage going indefinitely in order for this state to reach a greenhouse gas or carbon balance ultimately in the next 3 or 4 decades. Now, it turns out that the kind of deforestation level that the alumina industry is engaged in is a sizable fraction of the deforestation from this state. I can't give you a definitive figure, but our estimates are it's probably 60 or 70% of the actual deforestation emissions across the entire state in the last decade are coming from the bauxite alumina industry. Don't quote me on that. We're doing a report for WAFER at present, so those numbers need to be checked. So it's a non-trivial problem, even in that limited area of deforestation. So I think I can stop boring you with graphs and hand back for questions. Thanks.